sciencey, we do best. Missy helps you pass the test. Whee!
Hello and welcome to the How To series of science videos with me, Miss C. In these videos, we will tackle the topics which at the moment make your brain hurt and make them less painful. In this video, we're going to focus on how to calculate empirical formula and molecular formula. What is the empirical formula of a substance? Well, it's the smallest whole number ratio of atoms in a compound. What is the molecular formula of a substance? This is the actual number of atoms of each element in a single molecule. Now, you will be pleased or not to know that there is a process so that we can work out the empirical and molecular formula of a substance. As usual, my advice is to learn the process and then you can apply it to any question. Let's look at the steps in this process. Now, it's good practice to underline the numbers in the question to help you focus. So, firstly, you've got to list all the elements in the compound. Then you've got to write underneath their experimental masses. Then you've got to work out the number of moles of each element by dividing each mass by the relative atomic mass for that particular element. Then you turn the values you get into a ratio by dividing by the smallest number of moles, and then you convert the ratio into its simplest whole number form. So let's look at a worked example. So here's the question. Sodium metal tarnishes in air to form a layer of sodium oxide on its surface. 0.92 grams of sodium combined with 0.32 grams of oxygen in this oxide. Calculate the empirical formula of this sodium oxide. You're given the relative atomic masses of oxygen and sodium, so you don't have to worry about looking them up on your periodic table. And as ever with calculations, you've got to show you're working out. So let's follow the steps. List all the elements in the compound. So we've only got two, sodium and oxygen. So then next we've got to write down their experimental masses underneath. So from the question that you've already underlined these numbers. Sodium, it was 0.92 grams, and for oxygen, it was 0.32 grams. Then you've got to work out the number of moles by dividing each mass by the relative atomic mass for that particular element. So for sodium, you divide the value in the question by 0.32, and then oxygen, you divide the value given in the question by 0.32. So now you have got some mole values. So what we've got to do, we've got to turn the values into a ratio by dividing by the smallest number of moles. Okay, so here's our ratio now. And then we've got to convert the ratio into its simplest whole number form. So you can see we had a whole number value for oxygen, which was 1, so that just stays as 1. But when we worked out the moles for sodium, we had 2.875. So you can't have 2.875 of an atom. So we've got to do the whole number. So the whole number we round down to the nearest whole number, and in this case, it's 2. Now, typical follow-on question, converting empirical formula to molecular formula. 3 easy steps. Calculate the relative molecular formula of the empirical formula. Work out the factor that you'll apply to the formula mass. and then multiply the numbers in the empirical formula by the factor that you've just worked out. You now have the molecular formula of the substance. Again, 3 easy steps, and let's see those steps in action. So here's the question. The empirical formula for ethene is CH2. So the MR for ethene is 28. Work out the molecular formula for ethene. So let's dive in. Calculate the MR of the empirical formula. So ethene, the MR is equal to 14. Now we're going to work out the factor that we're going to apply to the formula mass given to us in the question. So we're told in the question the formula mass of ethene is 28. So we divide 28 by 14 and the factor we get is 2. And all we need to do now is multiply the numbers in the empirical formula by the factor we've just worked out, which is 2. So if you multiply 1 carbon by 2, you end up with 2 carbons. And if you multiply 2 hydrogens by 2, you end up with 4. So now we have the molecular formula of ethene. Let's look at another worked example. So in an experiment, it was found that 1.24 grams of phosphorus reacted completely with 1.60 grams of oxygen to form phosphorus oxide. The relative formula mass for this phosphorus oxide is 284. Deduce the molecular formula of this phosphorus oxide. So again, we are given the values, the relative atomic masses, so we don't have to look them up on the periodic table. And let's dive in by following the steps. List all the elements in the compound. So that's what we've got to do. We've got phosphorus and oxygen. Next, we've got to write down the experimental masses under the appropriate element. So for phosphorus, the mass from the question is 1.24 grams, and for oxygen, the mass from the question is 1.6 grams. So now we work out the number of moles. So we're given the relative atomic mass values in the question. So we do that. Then next, we have the number of moles. And now, all we've got to do is divide by the smallest amount of moles to get the mole ratio. So in this case, the smallest number of moles was 0.04. So there's our mole ratio, 1 to 2.5. And now all we have to do is convert the ratio into its simplest whole number form. So because we've got a half value for the oxygen, we can multiply it and we get the empirical formula for the phosphorus oxide is P2O5. So now we're going to convert to a molecular formula. So calculate the MR of the empirical formula. And now we're going to work out the factor to apply to the formula mass given to us in the question. And in the question, we're told that the formula mass for phosphorus oxide was 284. So you just divide by 142, and that gives us a factor of 2. So now all we do is multiply the empirical formula numbers by the factor 2 that we've just worked out. So now we've worked out the formula of this phosphorus oxide is P4O10. Genius. Easy peasy. I hope you found this video useful. If you have, please give it a thumbs up and hit subscribe so you'll be notified when more videos are added. If there are any other calculations in bio, chem or physics which make your head hurt and you'd like to see how you can make them hurt less, please add them to the comments box and you may see your request very soon.
All things sciencey, we do best. Miss C helps you pass the test. Whee!